Hey Winter, I'm just going to quickly go over some information about circuits that would be good to know. Sorry, I just kind of made a haphazard uh, frame here from my phone so I can take the video. So before we start on how to actually hook up LEDs to a circuit, I'll just go over quickly what LEDs are, how they work, and all that stuff. So there's a couple types of LEDs you can get. I like to use these little guys. I can't remember what they're actually called. I just call them like bulb LEDs. And you'll notice, let's see if I can get a good picture here. On these LEDs, they have a wire coming in that's attached to a very small plate. And the other wire comes in and attaches to a larger plate. You can kind of see there. So the small end is the positive lead for the LED, and the big flat plate is the negative lead. And with LEDs, because they're a diode, it means electricity can only flow one way through them. So it's really easy to tell. If you stick power onto your LED and it doesn't light up, chances are you have power going the wrong direction. The other type of LED, I don't know what they're called. Let's call them like nipple LEDs, because that's kind of what they look like. They're pretty small. Usually, I'm not sure if you can see it on here. Usually they'll have like a plus and a minus etched into one end, so you can kind of tell which way electricity flows through there. So it's pretty easy. The positive side of the battery goes into the plus side of the LED and then out the other side. And I'm sure you already know, but just in case, you have your battery hook up. It's got a red wire is positive. It's got a black wire is negative. So the positive wire goes to the little side, negative wire goes to the negative side. If you're ever looking like online and you see this symbol come up, it's like a little triangle with a line. It's the symbol for an LED or any kind of diode, I think. So the triangle is the positive side, the line is the negative side. The other thing you're going to want to know about are resistors. They're kind of what limit the amount of energy flowing into an LED. So they kind of look like little dumbbells. Here, I'll see if I can grab one. So they kind of look like little dumbbells. They're blue and they have a whole bunch of little different colored lines on them. Those lines tell you what the resistance is. I can go over that, but it's not really important. Usually on the bag, it'll have some information on it and it'll say like 20 ohms. And we'll go over what that is, but it's usually pretty clear on what kind of resistor it is. So if you're looking online and you see a diagram, a resistor is just symbolized by like a little sharp squiggly line. So for most of the LEDs that you work with, like especially these guys, these little bulbs, they almost always have a 2-volt drop, which means it eats up 2 volts when electricity is passed through it, and it requires 20 milliamps. We don't really need to go into what that is, but if you're going online and using a resistor calculator, which is what I suggest doing, they'll ask you what the voltage drop is and what the current is for each of them. So for resistors, you'll usually, for the stuff that you'll be doing, you'll probably be working with 10 to 100 ohm resistor. And that's what this little symbol is here. It's kind of like the Lululemon symbol. It's resistance or ohms. So it's pretty straightforward. So to calculate what kind of resistor you need, the resistance or the resistor number, like in this case 20 ohms is my R value. So R is equal to the voltage of your supply. So for instance, those square batteries are 9 volts, so that's a 9 there, minus the voltage of the LED. So for one LED, that voltage would be 2, divided by the current, which is that 20 milliamps, so that like Lululemon symbol. So there's a couple ways to get over the voltage draw for an LED. So like if you think about it, if you have a 9-volt LED and your LED takes like 2 volts, that means you can only put 4 LEDs together because they'll eat up 8 volts. So that kind of limits how many you can have. So to get around that, you set them up in a configuration called parallel, which is pretty simple. All it means is you have your battery, you have a long wire, and you attach all the positive sides of the LEDs to this one wire, and all the negative sides of the LEDs to the other wire. And what that does is the voltage doesn't actually add up. It's kind of weird. So if we had it set up like this, these are all 2-volt LEDs, this entire circuit would only eat up 2 volts of electricity. If you have them in series, however, it's like adding. You have one LED, which is 2 volts, another one, and another one. So if these were all 2 volts each, it would be a total of 6 volts. So a really good way to set up a circuit is to use both series and parallel. So for instance, in this case here, let's say we have a 6-volt battery, and I want to put as many LEDs as we can. So we're going to set this up into parallel. So each one of these series, which is like kind of like this whole thing here, this is going to do 2 volts, 2 volts, 2 volts, so 6 volts total. Same with this guy here. This is also going to take 6 volts. And now you got to figure out what kind of resistor you want in there. It's best to put a resistor in front of each one, because if something happens to like this guy here, this section will still work fine. You can, if you wanted, you could get that kind of centered there. You have your battery, you could have like one resistor and then have all of your LEDs stuck together. But yeah, I totally suggest doing this. It'll be really easy. Like the website that I showed you, it'll ask you, it'll say, okay, what's your voltage supply? You'll say, okay, let's say I'm using a square battery, which is like a 9-volt battery supply. It'll ask you what your voltage drop is. And because it's going to be asking, it's going to be calculating a parallel, what you do is for this voltage drop, you just add up all the voltages that you're going to have in your LEDs. So let's say I want to use 4 LEDs. It's going to be 4 times 2 volts per LED, so it's going to be 8. So it'll ask you for the voltage drop, you'll say 8 volts. It also has it'll also ask for like the current. It might ask for like I, which is like the symbol for current. Kind of when I'm talking about current, it's in an equation, it's symbolized by I. And you would just say 20 milliamps, which is pretty common for most of the LEDs that you work with. I'm not 100% sure on the voltage and current for the little nipple LEDs, but they're roughly the same, so you could stick that into the calculator and it should be okay. So what it'll do is it'll do some you'll plug your numbers in. 9 volts for the supply, 8 volts for your voltage drop. That's for 4 LEDs. That's 4 LEDs in series. So you would hook these LEDs up like this. So you'd have like your positive current coming in. You'd have the positive side of your LED, your negative side, your positive side, your negative side, and you just hook them up like that. So you have your 8 volts for all your LEDs, 20 milliamps for each LED. So it's like you don't have to add the milliamps, it's just for each one individually. And what it'll do, it'll say, okay, this is what your circuit looks like. And it'll tell you what your resistance should be. So I don't know, like maybe let's just say 58. I'm not sure what it actually is, but it'll pump out like 58 ohms or 58 like horseshoes or whatever you want to imagine it as, but it means 58 ohms. So you take the 58 ohms, you look at the bags you got, you look for the number that says 58. This is just 20, not 58, but you take that, and then you're going to use 58 ohms for your resistors, and your LEDs you're going to use just whichever ones you have, whether it's the bulb or the nipple. And then on the next video I'll go through on how to actually hook them up together.